and we'll keep drifting, floating together through the mysteries. 100 Star Nurseries mysteries are looping softly, endlessly through the night. Tonight we'll drift through the hidden cradles where stars are quietly born, the silent cosmic collisions that shape sparkling clusters, and the ancient clouds holding newborn stars you'll never see with your eyes. There's nothing you need to do now. Just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into Star Nurseries, in the deepest regions of space, where light takes millions of years to travel. There are clouds, vast clouds of gas and dust, drifting, turning, so slowly you'd never notice. These are the stellar nurseries, the cosmic cradles, where baby stars are born in absolute silence. Your eyelids growing heavy now, heavier, heavier, as we float through these ancient clouds. Imagine darkness, such complete darkness, colder than anything you've ever felt. Temperatures hovering just 10 degrees above absolute zero. Thump, thump, your heartbeat keeping time with the slow collapse of matter. Everything slowing down, down, down. These molecular clouds stretch across light years, so enormous that our entire solar system would be just a grain of sand. Lost inside them, they drift through the galaxy, patient, timeless, waiting. Some are dark nebula, blocking the light of stars behind them, creating holes in the night sky. Patches of black deeper than black, where the universe seems to have forgotten to place any light at all. Let your jaw release, unclenching, softening as we drift deeper. The clouds are mostly hydrogen, the simplest element, born in the first moments after the universe began, swirling now with helium and traces of heavier elements. Carbon, oxygen, nitrogen, forged in the hearts of dying stars that came before. Everything in space, recycled, reborn, drifting in endless cycles. Inside these clouds, something is stirring. The gas grows denser in certain pockets, clumping together, drawn by gravity's patient pull, matter calling to matter, each particle adding its tiny whisper of mass. Pulling more particles closer, the cloud begins to collapse in on itself, so slowly, taking millions of years just to shrink, just to tighten, just like your muscles releasing now, surrendering to gravity, sinking deeper into your bed. These dense pockets become protostellar cores, the very first stage of a star's life. They're cold, dark, hidden inside layers of dust. You couldn't see them with your eyes, even if you were floating beside them. But in infrared light, they glow, a subtle warmth, the first whisper of something waking, something gathering strength in the darkness. Your breathing is slower now, matching the rhythm of collapsing clouds, in and out, each breath like a cosmic wind flowing through stellar nurseries. The protostellar core continues its slow collapse, growing warmer at the center as gravity squeezes tighter, pressure building in the dark, heat rising 1 degree, then another, over thousands of years. Around these infant stars, disks of gas and dust begin to form, swirling, flattening into spinning pancakes of matter. These are accretion disks, feeding the growing protostar, material spiraling inward, falling onto the star's surface, releasing energy, creating a gentle glow, hidden beneath veils of cosmic dust, everything spinning, turning, like your thoughts beginning to spiral, softer, slower, less defined. Feel your body melting now, melting into the mattress, heavier. In these stellar nurseries, some protostars are destined to become massive, burning bright and dying young. Others will be small, red, smouldering quietly for trillions of years, all determined by how much gas the infant star can gather in those first few million years of slow, patient accretion. The dust in these nurseries isn't like dust on Earth. It's made of tiny grains, silicates, carbon compounds, even microscopic diamonds, forged in the atmospheres of ancient stars, each grain smaller than a particle of smoke. Yet together they shape the birth of worlds. They absorb light, scatter it, create the beautiful colours we see when we look at nebulae through telescopes, blues, pinks, deep reds, like a cosmic nursery painted in watercolours. Thump, thump, your heart barely noticeable now as you sink deeper. In some stellar nurseries, stars are born in pairs, binary systems, two protostars forming side by side, locked in an eternal dance, orbiting each other, some so close they'll eventually merge, others staying companions for billions of years, never quite touching, always circling like thoughts circling, fading as you drift. The most famous stellar nursery lies in the constellation Orion, the Orion Nebula, visible even to the unaided eye as a fuzzy patch. But inside that glow, thousands of stars are being born. The nebula is lit from within by young, massive stars, their ultraviolet light ionizing the gas, making it fluoresce like cosmic neon signs, announcing birth in colors of pink and green. Let your eyes rest, closed or nearly closed. It doesn't matter now. In the darkness of stellar nurseries, there are structures called Bok globules, small, dark, isolated clouds, each one a womb for a single star, or maybe two. They appear as dark spots against brighter nebulae, tiny pockets of privacy, where stars can form in solitude, away from the chaos of larger nurseries. Your thoughts are drifting now, scattered, soft, like dust grains floating through a nebula. Some stellar nurseries birth hundreds or thousands of stars at once, creating star clusters, All the stars born from the same cloud, siblings, sharing the same chemical signature, the same age. They'll drift apart eventually, scattered by gravity, by galactic tides. But for a while, they stay together, floating in the dark. These clusters come in two types: open clusters, loose collections that will eventually disperse, and globular clusters, ancient, tightly bound, containing hundreds of thousands of stars, all born in tremendous bursts of star formation. Long ago, when the universe was young and gas clouds were richer, denser, more eager to collapse into light, deep in the densest parts of molecular clouds, where even infrared light struggles to penetrate, the coldest stellar embryos hide. Temperatures of just 10 or 15 degrees above absolute zero. These prostellar cores haven't begun to collapse yet. They're balanced, perfectly poised, on the edge between drifting apart and falling inward. One tiny push, and they'll begin their journey toward becoming stars. Feel yourself on that same edge now, between waking and sleeping, balanced, ready to fall into deeper rest. The push that triggers collapse can come from many sources. A nearby supernova's shockwave, rippling through the cloud, or the gravity of a passing star, the pressure from stellar winds, even turbulence within the cloud itself, like invisible currents, stirring, churning, creating density waves. Turbulence is the hidden sculptor of stellar nurseries. Without it, clouds might never collapse. The chaotic motion, the random eddies, create regions where gas piles up, becoming dense enough for gravity to take hold. It's the spark that lights the flame, except the flame takes millions of years to ignite. Everything in space, patient, unhurried, drifting. Your muscles are completely soft now, no tension anywhere. Just like the gas in a molecular cloud, before it knows it will become a star. As protostars grow, something remarkable happens. They begin to expel material. Jets of gas shoot out from their poles, perpendicular to the accretion disk. These protostellar jets travel at hundreds of kilometers per second, piercing through the surrounding cloud, creating shock waves that glow in visible light. Where these jets slam into the surrounding gas, they create glowing knots called Herbig-Haro objects, named after the astronomers who studied them. These are the tantrums of newborn stars, violent outbursts from infants barely 1,000,000 years old. The jets carry away excess angular momentum, allowing more material to fall onto the star. It's a delicate balance between gathering and releasing, inhaling and exhaling, like your breath now, slow, steady, effortless. Let your attention drift to the colors, if you can still see them, behind your closed eyes. Star-forming regions glow in hydrogen, alpha light, deep red, because hydrogen is everywhere, being excited by ultraviolet radiation. Green comes from doubly ionized oxygen, blue from scattered light off dust grains. Each color tells a story about temperature, density, composition. But you don't need to remember. Just let the colours float, washing over you. Some of the most beautiful stellar nurseries are called emission nebulae. They glow because their gas is ionized, energized by young hot stars nearby. The most massive stars, O-type and B-type, burn so hot their surfaces reach 30 or 40,000 degrees. These stellar behemoths flood their surroundings with ultraviolet light, stripping electrons from hydrogen atoms. The gas recaptures those electrons, and in doing so, emits the light we see, a soft, persistent glow. Thump, thump, barely audible now, your heartbeat fading into the background. In some nurseries, the massive stars are so powerful they begin to destroy the very cloud that birthed them. Their stellar winds push away the gas. Their radiation evaporates it, carving cavities, creating pillars, like the famous pillars of creation in the Eagle Nebula. These pillars are enormous columns of gas and dust, resisting erosion, protecting smaller pockets where stars still form. At the tips of these pillars, small globules of denser gas, called evaporating gaseous globules or eggs, contain infant stars, cocooned, shielded, but eventually, even these will be stripped away. The pillars themselves will be eroded, dissolved by light and wind, revealing the stars within, or destroying them before they fully form. Creation and destruction happening together in slow motion. Over millennia, feel yourself dissolving now, boundaries softening, melting into sleep. In the densest stellar nurseries, stars form so close together they interact, gravitationally bound while still in their infancy. Some steal gas from each other's accretion disks. Others merge, becoming more massive. These embedded clusters are hidden inside their natal clouds, shrouded in dust, detectable only through infrared telescope that see through the veil. The infrared glow reveals protostars at every stage, some still deeply embedded, Class 0 protostars, more envelope than star, others slightly more evolved, Class 1 with prominent accretion disks, then Class 2, T-Tauri stars, young stars still surrounded by disks, but visible in optical light, finally shedding their dusty cocoons. Each class a stage of growth, like human development, infancy to adolescence, happening over millions of years. Your thoughts are barely thoughts now, just impressions, feelings, drifting. T-Tauri stars are named after the first one discovered in the constellation Taurus, another stellar nursery. These are sun-like stars, less than 10 million years old. They vary in brightness, flickering as material from their disks falls onto their surfaces, creating hot spots. They're still contracting, not yet sustained by nuclear fusion, glowing from gravitational energy, like embers, slowly heating. Around these young stars, something magical is already happening. Planets are forming. In the accretion disk, dust grains stick together through static electricity, through ice binding them, growing from microscopic specks to pebbles to boulders to mountain-sized planetesimals, all while the star itself is still being born. Planetary systems and star, growing up together in the quiet of the nursery. Feel your heartbeat in your fingertips now, or don't. It doesn't matter. In the outer regions of protoplanetary disks, beyond what's called the frost line, water can freeze. This is where giant planets form, where icy worlds are born. Inside the frost line, it's too hot for ice. Only rock and metal survive. This invisible boundary, drawn by temperature, by distance from the infant star, decides the fate of entire worlds before they even exist. Some protostars never quite make it. They're called brown dwarfs, failed stars. They form the same way as stars, through the collapse of gas clouds, but they don't gather enough mass, never quite reaching the threshold for hydrogen fusion, somewhere around 80 times Jupiter's mass. They glow dimly from leftover heat, fading slowly over billions of years, neither star nor planet, drifting in between. Let yourself drift there now, in between, not awake, not quite asleep, floating in the warm darkness. Brown dwarfs populate stellar nurseries quietly, outnumbering massive stars, hiding in the shadows, too faint to see easily. But they're there, quiet witnesses to the births around them, barely glowing in infrared, like embers slowly cooling. Magnetic fields thread through stellar nurseries, invisible, powerful. They shape the collapse of clouds, channel the flow of gas, guide the formation of jets. Without magnetic fields, stars would form differently, maybe faster, maybe not at all. The fields are frozen into the gas, moving with it, twisting, braiding, creating complex geometries that astronomers are only beginning to map in detail. These magnetic fields can break the rotation of forming stars. As the cloud collapses, it should spin faster, like a figure skater pulling in their arms, but magnetic fields linked to the surrounding cloud act like anchors, slowing the rotation. This is called magnetic braking. Without it, protostars would spin themselves apart before they could ignite, everything in balance, held together by forces you can't see, just like sleep, holding you now, softly, gently. Your breath is barely a whisper. In, out, in, out. Some stellar nurseries are triggered into existence by external forces. A supernova explosion nearby sends a shock wave through space, compressing any molecular clouds it encounters. The compression increases density, triggers gravitational collapse, and suddenly, where there was calm, there is birth. Supernovae are both destroyers and creators, ending old lives, sparking new ones. The elements forged in the supernova, carbon, oxygen, iron, become part of the new stars and the planets that form around them. This is how our own sun was born, probably from a cloud compressed by a nearby supernova. This shock wave that killed one star gave birth to ours and to us. We are made of stardust, from stellar nurseries, from ancient explosions. Everything in your body was once inside a star or scattered in a nebula, waiting to become something new. Feel that connection now to the cosmos, to the nurseries where light is born. Your atoms are billions of years old, forged in stellar cores, scattered in death, gathered again in new life. You are the universe, experiencing itself, and now the universe wants to rest, to drift, to sleep in the gentle dark. In some stellar nurseries, instead of individual stars, entire clusters ignite nearly at once. These starburst regions, found in colliding galaxies or in the centers of spirals, create thousands of massive stars in a few million years. The energy output is immense, lighting up entire galaxies. The combined stellar winds and supernova from these young massive stars blow away most of the remaining gas. Choking off further star formation, the nursery destroys itself through its own fertility, leaving behind only a cluster and silence. Within the Milky Way, stellar nurseries follow the spiral arms, where gas clouds naturally compress as they flow through the density waves. The spiral arms aren't solid structures, they're traffic jams, regions where gas piles up, slows down, and in slowing, triggers collapse, triggers birth. As the galaxy rotates, new gas enters the arms. The process continues. Stars are born, move out of the arms, and drift into the space between. Each generation following the one before in an endless, gentle rhythm. Thump, thump, or maybe your heart has stopped, just for a moment before beginning again, slow, slower. In the quiet spaces between spiral arms, star formation nearly ceases. The gas is too diffuse, spread too thin. But in the arms, in the regions of compression, nurseries light up, like flowers blooming along a path, temporary, beautiful, then fading as the gas is exhausted. Some of the largest stellar nurseries in our galaxy are found in the Carina Nebula, the Tarantula Nebula in the Large Magellanic Cloud. These are sites of massive star formation, where dozens of O-type stars, the largest stars that can exist, are born within the same few million years. These giants burn so hot, live so fast, they'll explode as supernovae before smaller stars have even reached the main sequence. Speed and patience, existing side by side. Let your mind rest on that paradox, or don't. Let it slip away. Stars live at different speeds. Massive stars racing through their lives in a few million years. Small red dwarfs, living for trillions, longer than the current age of the universe, all born in the same nurseries from the same clouds, but walking different paths at different paces, just drift. There's no hurry, nowhere to be. In the darkest stellar nurseries, the ones called infrared dark clouds, star formation is just beginning. These clouds are so dense and so cold, they block even infrared light, appearing as dark patches, against the bright galactic background. Inside them, prostellar cores are forming, gathering mass, preparing to collapse. These are the youngest nurseries, still in stealth mode, factories not yet operational, but soon, they'll light up. Submillimeter telescopes can peer into these dark clouds, detecting the faint thermal emission from dust grains, just a few degrees above absolute zero. The observations reveal structure, filaments of denser gas threaded through the cloud like veins or nerves. Along these filaments, cores form like beads on a string, each bead a future star. The filaments feed them, channeling gas from the larger cloud, everything connected, flowing, like your consciousness now, flowing away. Feel the weight of your body, or the absence of weight, floating. You are barely here. In stellar nurseries, time moves differently. A human lifetime is nothing, less than a heartbeat in the formation of a star. What seems eternal to us is just a moment to the universe, and yet we're here, witnessing, drifting through these mysteries, together, in the dark. Some stellar nurseries produce runaway stars, born in clusters. These stars gain too much velocity through gravitational interactions and escape. They're ejected from the nursery, traveling through space at normal speeds, dozens of kilometers per second faster than their surroundings, moving alone, forever separated from their siblings, drifting through the galaxy, trailing faint bow shocks as they plow through interstellar gas. Everything drifting, including you, your awareness scattering like gas in a disrupted molecular cloud. The molecular clouds themselves are made mostly of hydrogen molecules, H2, but also carbon monoxide, water, ammonia, even alcohol, complex organic molecule floating in space. The chemistry of these clouds is rich, surprisingly diverse, building blocks of life, forming naturally in the cold and the dark. These organic molecules include formaldehyde, methanol, even amino acids, the building blocks of proteins, discovered in meteorites that fell from stellar nurseries. This means the chemistry of life begins before planets exist, in the clouds where stars are born. We are not just made of stardust, we are made of the molecular clouds themselves, our origins, in the darkness, in the cold, in the quiet, cradles of space. Listen to the silence between beats. In that silence, stars are forming, right now, in nurseries across the galaxy. Somewhere, a protostellar core just began its collapse. Somewhere, a jet erupted from a newborn star. Somewhere, a planet condensed from dust. All happening while you lie here, sinking deeper, all happening in perfect silence. Because space carries no sound, the gas in molecular clouds moves at just a few kilometers per second, barely drifting. Yet that gentle motion over millions of years is enough to compress, to collide, to trigger birth. Small motions adding up to enormous change, like you're breathing, small, gentle, each breath a tiny motion but together they keep you alive, keep you drifting towards sleep, deeper and deeper still. In the centers of some molecular clouds, gravity pulls the gas inward from all directions, creating spherical cores called Bonner-Ebert spheres, perfectly balanced between internal pressure pushing out and gravity pulling in. Thespheres are stable until something disturbs them, a density wave, a magnetic field realignment. Then they collapse, inevitably, falling into themselves, like you're falling now into the soft, warm darkness of sleep. The collapse accelerates, slowly at first, then faster. The core heats up as gravitational energy converts to thermal energy. Eventually, and the center becomes hot enough, dense enough for nuclear fusion to begin. Hydrogen nuclei, forced together, overcome their electric repulsion, fuse into helium, releasing energy, light. A star is born, but that moment, that ignition, takes millions of years to reach. Patience, infinite patience, rewarded with light, and light spreads outward, pushing through the dust, warming the surrounding cloud, ionizing nearby gas. The newborn star announces itself to the universe after so long, in silent preparation. The dust around it glows, reflecting and scattering the starlight, creating what astronomers call a reflection nebula, soft blues and whites, lit gently from within, like consciousness, glowing softly before fading into sleep. Some stellar nurseries span hundreds of light years, giant molecular clouds, so massive they contain millions of solar masses of gas, enough to birth millions of stars. They're the largest structures in the galaxy, besides the galaxy itself. Yet even these eventually dissipate, torn apart by the very stars they create, their stellar winds, their supernova, their radiation, slowly, patiently eroding the cloud, returning the gas to the interstellar medium, where it will drift, gather, and one day collapse again. Everything cycles: birth, life, death, rebirth. The universe endlessly recycling itself, creating new forms from old materials. Your body does this too. Every few years, nearly every atom replaced, yet you remain somehow continuous, like a molecular cloud, reformed from the remnants of those that came before. You are not a fixed thing. You are a process, a flow. And right now, that flow is carrying you gently, softly, toward sleep. Feel yourself dissolving into that flow, your boundaries, uncertain. Are you the mattress, the air, the darkness? It doesn't matter. Let it all blur together. In stellar nurseries, the boundary between cloud and star is equally uncertain. Where does the cloud end and the protostar begin? There's no sharp edge, just a gradient, a smooth transition from diffuse to dense, from cold to warm, from dark to glowing. The universe is full of gradients, gentle transitions, nothing sudden, nothing jarring, just smooth, flowing change. Let yourself be part of that, drifting along the gradient from waking to sleeping, so gradually you can't tell when one becomes the other. And in the stellar nurseries the process continues, stars forming, clusters gathering, nebulae glowing, all in the darkness, in the cold, in the silence of space, where light is born from shadow, where something comes from nothing, or maybe not nothing, maybe from potential, from the gentle, patient collapse of what was scattered, becoming focused, becoming whole. Your breathing is so soft now, barely moving, like the motion of gas in a molecular cloud, just drifting, stirring, settling. And in that settling, something new can form, something beautiful, emerging from the quiet, the darkness, the endless, patient, waiting, thump, thump. Or is that the pulse of the universe itself, beating slowly through everything, through you, through the stellar nursery, through the stars, all connected, all part the same vast, dreaming cosmos? Let yourself merge with that dream. You are the universe, dreaming itself into existence. And right now, the dream is gentle, soft, pulling you down, down into the deep rest, the endless, quiet, where stars are born in silence, and you can finally, completely, absolutely let go. The stellar nurseries keep forming, keep glowing in the dark, patience beyond measure, creating light from shadow, and you floating through them, witnessing, drifting, becoming part of the gentle, endless cycle. More mysteries await, deeper, softer, quieter, as we drift together through filaments, through cores, through the hidden places where light begins, through the filaments, gossamer threads of gas, stretching across light years, connecting one stellar cradle to another. Your body completely released now, no effort, no holding, just sinking heavier, heavier into the mattress, into the dark. These filaments are the highways, the channels through which gas flows, feeding the hungry cores where protostars wait, patient, gathering mass, one molecule at a time, over millions of years. Your heart barely a whisper. The filaments form naturally, from turbulence, from gravity, from magnetic fields guiding the flow. They're denser than the surrounding cloud, cooler, more stable, like rivers of invisible fog, winding through space, and along these rivers, cores condense, like dewdrops forming on a spider's web, each drop a future sun waiting in the cold, the dark, the silence. Feel your thoughts becoming like those filaments, thin, stretched, barely there, connecting one drowsy image to another. Nothing solid, just wisps, drifting, fragmenting. In some stellar nurseries, the filaments are enormous, thousands of solar masses flowing slowly, imperceptibly toward the cores. The process is called hierarchical fragmentation. The large cloud fragments into filaments, The filaments fragment into cores, the cores fragment sometimes into multiple stars, everything breaking down into smaller pieces, like your awareness now, breaking, softening, dissolving. Within the densest cores, pressure begins to build. As more gas falls inward, the center compresses, heats. The temperature rises from 10 degrees above absolute zero to hundreds, then thousands of degrees. But this takes time, so much time. A core might collapse for 100,000 years before fusion begins, before the star truly ignites. Everything's so slow, so patient, like the drift towards sleep, imperceptible, until suddenly you're gone. Let your jaw soften, your tongue resting, loose, in your mouth. No tension anywhere. In the cores, molecules begin to break apart as temperature rises. First the complex molecules, the organic chemistry, dissociates. Then hydrogen molecules split into individual atoms. The core becomes a plasma, a soup of charged particles, swirling, compressed, glowing faintly in infrared, invisible to your eyes, but there, heating, waiting. Some protostars take millions of years to emerge from their cocoons. These are the low-mass stars, sun-like and smaller. They form slowly, gently, accumulating mass at a leisurely pace. Their accretion disks feed them gradually. No rush, no urgency, just the patient pull of gravity, drawing matter inward, bit by bit, like breath, flowing in and out, so gently, you barely notice, until you realize you've been breathing slower and slower, still, thump, thump. The most massive protostars form differently. They're voracious, consuming gas rapidly. Their accretion rates are hundreds of times higher. They heat up faster, ignite fusion while still gathering mass, still surrounded by their natal clouds. These are the O-type stars, the blue giants, burning so hot their surfaces glow with ultraviolet fire. They live fast, die young, exploding as supernovae after just a few million years. But in that brief time, they reshape their nurseries, carving cavities, triggering new collapse in nearby clouds. The radiation from massive protostars creates ionization fronts, waves of energy that eat away at the surrounding gas. The fronts advance, slowly, pushing into the molecular cloud, stripping electrons from atoms. The ionized gas glows, marking the boundary between the star's influence and the cold neutral gas beyond. These fronts carve pillars, create sculptures like cosmic erosion, weathering the cloud into fantastic shapes that last for just a moment in cosmic time before dissolving into nothing. Your thoughts are like that now, carved, shaped, but dissolving, fading. You can't hold on to them. They slip away like gas eroding from a pillar, each thought less defined than the last. Everything softening into the gentle, formless drift. In stellar nurseries viewed through different wavelengths, different truths emerge. invisible light, you see the glowing ionized gas, the reflection nebulae, but in infrared. You see through the dust to the protostars hidden inside in radio waves. You detect the cold molecular gas, the raw material. In X-rays, you see the violence, the jets, the shocks, each wavelength a different story of the same slow birth. Masers appear in collapsing clouds. These are like cosmic lasers, naturally occurring, where molecules become excited and emit coherent radiation. Water masers, methanol masers, hydroxyl masers. They mark regions of intense activity, collapsing cores, protostellar jets, accretion disk boundaries. Astronomers use them as beacons to find deeply embedded protostars, otherwise invisible, hidden in their dusty wombs, waiting to be discovered. Let your eyes rest, completely still, behind closed lids, in the stellar nurseries. Motion never stops. Gas flows, disks rotate, jets stream outward, but it's also slow. From our perspective, you could watch for an entire lifetime and see almost no change, just like watching yourself drift towards sleep, the change so gradual you don't notice until you're already gone. The accretion disks around protostars are already forming planets. Even before the star ignites, dust grains stick together through electrostatic forces, through icy mantles binding them, growing from microscopic to millimeters to centimeters. This is slow, delicate work. The grains drift through the disk, colliding gently, sometimes sticking, sometimes bouncing apart. Gradually, inevitably, they grow into pebbles, into boulders, into planetesimals, miles across, massive enough that their own gravity pulls in more material. This process creates gaps in the disk, rings and gaps, like ripples, where forming planets have cleared their orbits, sucking up nearby material. Telescopes can see these structures now in nearby stellar nurseries, direct evidence of planets forming in real time. Well, real cosmic time. The process still taking millions of years, everything patient, slow, building something new from scattered dust, your heartbeat fading into background, into silence. Beyond the frost line, in the outer disk, ices can form. Water ice, methane ice, ammonia ice. These ices make up the cores of giant planets. The solid material is more abundant, allowing the cores to grow large enough to capture hydrogen and helium from the surrounding disk, becoming gas giants like Jupiter, like Saturn, massive worlds born from ice and dust in the cold, outer regions of the stellar nursery. Inside the frost line, only rock and metal survive. These form terrestrial planets, smaller, denser, worlds like Earth, Venus, Mars. The frost line moves inward as the protostar heats up and outward. In the earlier stages, it's an invisible boundary, deciding fate, determining which worlds will be giants and which will be rocky, all from temperature, from distance, from the gentle gradient of heat spreading through the dark. Feel that gradient now. Warmth where your body touches the bed, coolness in the air, everything in gradient, in transition. Nothing fixed, nothing final, just flowing, changing, so gently you barely notice. Some stellar nurseries experience triggered star formation. A supernova shockwave from a nearby region compresses the cloud, or the passage through a galactic density wave, or the collision of two molecular clouds. Suddenly, or as suddenly as anything happens in space, the cloud begins to collapse in many places at once. A cascade of star formation spreading through the nursery like dominoes, each new star potentially triggering more collapse in adjacent regions. Their nursery lights up with dozens, hundreds of new protostars, all born within a few million years, siblings sharing the same origin, the same trigger. These starburst events can exhaust a molecular cloud quickly. The combined feedback from the young stars, their winds, their radiation, their eventual supernova drives away the remaining gas. The stellar nursery self-destructs, leaving behind only a star cluster and the memory of the cloud that once existed. Everything temporary, even stellar nurseries, forming, shining, fading, like thoughts, like consciousness, flickering, then gone. Your breath is barely moving now, the shallowest whisper. In stellar nurseries, some regions birth twins, binary star systems where two protostars form close together, locked in gravitational embrace. They share an accretion disk sometimes, a circumbinary disk, feeding both stars. The disk has a hole in the middle, cleared by the orbital motion, creating rings of material, spiraling inward, falling onto first one star, then the other, an eternal dance of give and take. Most stars are born in binaries, or in multiple systems. Lone stars, like our Sun, are less common. Most have companions, some so close they touch, sharing their outer atmospheres. Others separated by thousands of astronomical units, barely bound, orbiting once every million years, all formed together in the same collapsing core that fragmented, split into two or more centers, each becoming a star. Let yourself fragment, dissolve into multiple pieces, or into no pieces, into everything, into nothing. It doesn't matter now. In wide binary systems, the stars barely interact. Each has its own planetary system, its own evolution. They're siblings who live apart, connected only by the weak thread of gravity, drifting through the galaxy, together but separate, like your body and mind now, together but separate, dissolving into different rhythms, different speeds, thump, thump. Some stellar nurseries produce exotic objects called Herbig-Haro objects. These are visible as patches of nebulosity, bright knots in the dark. They form where protostellar jets slam into the surrounding molecular cloud at hundreds of kilometers per second. The shock heats the gas, making it glow. These objects move, actually move, visibly over years or decades, as the jet continues to plough through the cloud. They're the tantrums of infant stars, proof of the violence hidden inside the gentle, slow collapse. The jets themselves are narrow, tightly collimated beams of gas and dust. They can extend for light years, piercing through the cloud, carrying away angular momentum and energy. Without these jets, protostars would spin too fast and overheat. The jets are safety valves, releasing pressure, allowing the star to form properly, slowly, everything in balance, every force, every pressure, every flow, perfectly tuned to create light. In the coldest stellar nurseries, temperatures hover around 10 Kelvin, just 10 degrees above the lowest possible temperature. At these temperatures, molecules move slowly, barely vibrating. Gas atoms drift gently toward each other, stick together, forming larger molecules. Complex organic molecules can form, protected from radiation by the dense dust. Chemistry happens in the dark, in the cold, building blocks of life assembling without any life to guide them. Your body is cooling now as you relax, as blood flows more slowly to your skin, everything settling, slowing, matching the temperature of the universe, the cold, the quiet, the stillness of space between the stars. Some protostars are variable. They flicker, changing brightness over days or weeks. These are called young stellar objects, or YSOs. Their variability comes from many sources, material falling from the disk in clumps, creating bright spots, or the rotation of the star, with cooler spots passing in and out of view, or instabilities in the accretion disk, causing it to brighten, then dim. The infant star is restless, unsettled, not yet stable, still figuring out how to be a star. But eventually, after millions of years, the accretion stops. The disk is consumed, either falling onto the star or blown away, or coalescing into planets. The star settles onto the main sequence, where it will burn hydrogen steadily for billions of years. The nursery phase is over. The star has been born, emerged from its cocoon, and drifts into the galaxy to begin its long, slow life. Feel yourself settling too, like a star reaching equilibrium, your body finding its balance between waking and sleep, between effort and rest, settling into the main sequence of sleep, where you'll rest steadily, deeply, for hours. In some stellar nurseries, the feedback from the first massive stars prevents further star formation. The radiation pressure, the stellar winds, push away the remaining gas. The cavity expands, a bubble of hot ionized gas surrounded by a shell of compressed neutral gas. The shell might collapse, forming a new generation in the compressed ring, but often the gas just disperses, returns to the interstellar medium. The nursery ends, the lights go out, only the stars remain, drifting slowly apart These stellar bubbles can be enormous, hundreds of light-year across, carved by the winds and supernovae of massive star clusters. They're called superbubbles, and they shape the structure of galaxies, channels through which hot gas can escape, flowing out of the galactic disk into the halo. Stellar nurseries don't just create stars, they reshape their entire environment, leaving scars that last for millions of years after the nursery itself has faded. Let your environment fade now, the room, the bed, the sounds, everything becoming distant, unimportant. Only the darkness remains, soft, warm, infinite, like the space between stars, where stellar nurseries drift, waiting to collapse, to birth, to shine. In the centers of galaxies, where gas is abundant, stellar nurseries form continuously. These are sites of ongoing star formation, regions where the gas never runs out, fed by flows from the outer galaxy or from gas falling in from the intergalactic medium. The star formation can continue for billions of years, creating generation after generation of stars. Each wave of star formation slightly enriching the gas with heavier elements, making the next generation slightly different, slightly richer in the metals forged by previous stars. Our sun is one of these later generations, formed from gas, already enriched by perhaps 50 generations of previous stars. All the iron in your blood, the calcium in your bones, the oxygen you breathe was forged in stellar cores billions of years ago, scattered by supernovae, gathered into a new stellar nursery and incorporated into the sun and the planets, and eventually into you. You are stardust, literally. Atoms forged in stellar furnaces, assembled in a stellar nursery 5 billion years ago. And now, those atoms rest here, in the dark, returning, if only briefly, to the stillness, quiet, the peace of the cosmic void, before they were disrupted by fusion, by light, by life. Thump, thump, or maybe your heart has stopped and started and you didn't notice. Time becoming uncertain, elastic, stretching. In stellar nurseries, time moves differently for different objects. For the massive protostars, evolution is fast, millions of years from collapse to main sequence. For the smallest, brown dwarfs and red dwarfs, the process is slower, tens of millions of years, all happening simultaneously in the same nursery. Different speeds, different time scales, all coexisting. Some stellar nurseries are hidden, not by dust, but by distance. Infrared dark clouds in the outer galaxy, too far to see clearly, or stellar nurseries in other galaxies, visible only as bright patches, unresolved, each patch containing perhaps thousands of protostars, each with its own story, its own evolution. But from here, just a smudge of light in the dark. The Tarantula Nebula in the Large Magellanic Cloud is one of the largest stellar nurseries visible from Earth. It's so bright it would cast shadows if it were as close as the Orion Nebula. Inside it, hundreds of massive stars have already formed, and thousands more are still in their cocoons, waiting to emerge. The nebula glows, fierce and bright, pink and red and blue, a riot of colour from the chaos of birth. But you don't need to see colours now, just the darkness behind your closed eyes, gentle, soft, formless. Let the nurseries glow somewhere far away while you rest here in the quiet, the stillness, drifting. In some collapsing clouds, the fragmentation creates not just double stars, but triple systems, quadruple systems, small clusters bound together, orbiting a common center of mass. These systems are complex gravitationally. Orbits can be unstable. Stars can be ejected or collide, yet many remain stable for billions of years, dancing their intricate dance in perfect balance. Your breath and heartbeat, finding their balance, their rhythm, synchronized or not synchronized. It doesn't matter. Everything finding its own pace, its own orbit. In the dark, photoevaporation occurs when ultraviolet light from massive young stars heats the surface of molecular clouds and protoplanetary disks. The heated gas escapes, flowing away, evaporating into space. This limits how much mass a protostar can gather and how long a protoplanetary disk can survive. The disks around stars, near massive O-type stars, evaporate in a few million years. Those far away can persist for 10 million years or more. Time enough for gas giants to form, or not, depending on the neighborhood in which the star was born. Some protostars experience outbursts, sudden increases in brightness as material from the disk falls onto the star in a surge. These are called FU Orionis events, named after the first one discovered. The star can brighten by 100 times and stay bright for decades or centuries before fading again. These outbursts may be common in the early life of all stars, including our Sun, evidence written in meteorites in the solar system's oldest rocks of a young sun, flickering, erupting, still learning how to shine. Let yourself brighten for just a moment, a flicker of awareness before fading deeper into the darkness. Nothing to hold on to, nothing to remember, just the gentle flow carrying you down and down and down. In stellar nurseries beyond the Milky Way, in distant galaxies, the process is the same. Clouds collapse, protostars form, jets erupt, stars are born. The physics, the chemistry, identical across the universe. Only the details differ. The composition of the gas, the density of the clouds, the presence or absence of metals. But everywhere stars can form. They do form in nurseries, hidden and bright, ancient and new, the universe creating light from darkness, everywhere, always, endlessly. Some of these distant nurseries existed when the universe was young, when the first galaxies were forming. Population 3 stars, born from pristine hydrogen and helium, no heavier elements yet. Their nurseries were different, denser, more prone to forming, very massive stars. These stars burned bright and fast, exploded quickly, seeding the universe with the first metals, making possible all the generations that followed. We've never seen a population 3 stellar nursery. They're too far away, too faint, their light too red-shifted. But we know they existed because we exist, because the metals in our bodies had to come from somewhere, from those first massive stars exploding in the ancient universe, scattering their enriched gas into space, where it drifted, gathered, collapsed, and formed new nurseries, new stars, new worlds, leading eventually us through billions of years to this moment, to you, lying here, drifting into sleep. The gravitational collapse of a prestellar core follows predictable patterns described by equations, Bohr-Ebert stability, Jeans mass, virial theorem, the mathematics of gravity, and pressure and temperature, all balanced, all determining when collapse begins and how fast it proceeds. The universe governed by laws is by forces, by fields, all pushing, pulling, shaping the formation of stars. But you don't need to understand the mathematics. Just feel the pull of gravity, holding you to the earth. Feel the pressure of the mattress supporting you. Feel the temperature of your skin cooling as you rest. All the same forces on a different scale. Everything connected, from the stellar nurseries to your body, lying here in the dark. Some stellar nurseries are shaped by turbulence, supersonic flows of gas colliding, creating shocks, creating density variations that seed gravitational collapse. Without turbulence, clouds might be too uniform, too stable to fragment, to form stars. It's the chaos, the disorder that enables creation, that makes structure from uniformity, something from nothing, or not nothing, but something new from something old. Feel your thoughts becoming turbulent, chaotic, scattered, no longer following linear paths, just swirling, mixing, fragmenting into smaller pieces, smaller, until they're too small to notice, too faint to matter, just noise, fading into silence. In embedded clusters, newborn stars hide within their natal clouds, so dense, even infrared light struggles to penetrate. Only submillimeter telescopes can detect them, revealing clusters of dozens or hundreds of protostars packed closely together. They'll interact gravitationally, exchange energy. Some will be ejected, others will sink toward the center, everything in motion. Even when hidden, even in the dark, the dance continues. These clusters will eventually emerge as the gas is blown away. They'll become open clusters like the Pleiades, like the Hyades, groups of stars drifting through the galaxy together, bound loosely by gravity. Eventually, over hundreds of millions of years, they'll disperse, each star going its own way, siblings scattered across the galaxy, but carrying always the memory of their shared birth in the darkness of the nursery. Thump, thump, barely there, your pulse so slow, so quiet, like the drift of stars in a dissolving cluster, moving apart so gradually you'd never notice unless you watched for millions of years. Let yourself disperse now, your awareness, your sense of self, loosening, spreading until you're not sure where you end and the darkness begins. No boundary, no edge, just gradual, fading, dissolving into the infinite, gentle, dark. And in the stellar nurseries, the cycles continue. Clouds collapse, stars form, live, die, explode, scatter their material, which drifts, gathers, forms new clouds, new nurseries, new stars, endless, eternal, the universe recycling itself, creating, destroying, creating again. And you, part of that cycle, resting now in the quiet moment between creation and dissolution, just drifting, floating softly through the mysteries of light, born in darkness, of silence, holding sound, of nothing, becoming everything. More secrets wait in the deepest nurseries, where the younger stars hide, where collapse has only just begun, and deeper still we drift into the most extreme stellar nurseries, where conditions push the boundaries of star formation itself. Your breath so shallow now, barely moving, as we float toward the centers of galaxies where everything is more intense, more chaotic, more extreme. Thump, thump, in the galactic center where our Milky Way's heart beats, stellar nurseries form in impossible conditions, the density of stars 1,000,000 times higher than in our solar neighborhood, tidal forces from the supermassive black hole, stretching, twisting, pulling clouds apart, yet stars still form somehow, defying the chaos, finding a way to collapse, to ignite in the most hostile environment imaginable. Let your muscles release completely, heavier, heavier. These central nurseries produce massive stars, preferentially the intense radiation, the strong tidal forces, the frequent collisions, all favor the formation of giants, O-type behemoths that burn fierce and die young. Their light floods the galactic core, creating a brilliant, dangerous, stellar factory at the heart of everything. When galaxies collide, their gas clouds slam together at hundreds of kilometers per second. The collision doesn't destroy, it compresses, triggering the most violent star formation in the universe. Starburst galaxies, forming thousands of solar masses of new stars every year, entire generations born in the chaos of merger, their nurseries stretched, compressed, ignited, by gravitational violence. Feel yourself merging with the darkness, boundaries dissolving. You don't know where you end and sleep begins. In these merger nurseries, gas streams in complex patterns, spiraling inward, feeding multiple sites of intense collapse. The nurseries light up like fireworks across the colliding galaxies, brief, brilliant, then fading as the gas is exhausted. Thump, thump, barely there in the crowded cores of stellar nurseries. Not every protostar succeeds. Some gather just 50 or 60. Jupiter masses, not enough for hydrogen fusion. These are the failed stars, the brown dwarfs glowing dimly from leftover warmth. They populate nurseries quietly, outnumbering their successful siblings, forever dim, forever cooling. Your thoughts like brown dwarfs now, barely glowing, fading, losing heat, losing definition. They drift through your mind, unnoticed, unremarkable, just shadows of what thoughts used to be. Everything dimming, everything cooling as you sink deeper into rest. These failed stars have their own quiet legacy. They stir the gas through their gravity. They trigger turbulence, influence fragmentation. Even in failure, and they shape their environment, invisible, unnoticed, but present, affecting everything near around them, like you're breathing now, so quiet. You've forgotten it, but still, it continues, shaping, sustaining. Let your jaw soften, tongue loose. In the coldest prostellar cores, before collapse begins, the gas is coated in frost, water ice, carbon dioxide ice, methane ice, forming sheaths around dust grains. These frosty envelopes protect complex molecules, shield them from radiation, allow chemistry to proceed in the frozen dark. The ice acts as a library, recording the history of the cloud. Every atom that sticks, every molecule that forms, frozen in place, waiting. Someday, when the protostar heats, the ice will evaporate, releasing its cargo into the forming planetary system, delivering water, organic compounds, the ingredients of life from the frozen nursery to warm worlds. Feel the coolness now of your skin, temperature dropping as you relax, as metabolism slows, your body becoming like those frozen cores, quiet, still, preserving. Everything slowing down, down into the cold, patient stillness. Thump, thump. In some stellar nurseries, magnetic fields grow too strong. The field lines thread through the gas, creating tension, resisting collapse. When magnetic pressure exceeds gravitational pressure, the cloud cannot fall, cannot fragment, cannot form stars. The magnetic field strangles birth before it begins. These magnetically strangled clouds can persist for millions of years longer than they should. The gas trapped, unable to collapse, slowly leaking across field lines through ambipolar diffusion, neutral atoms, drifting away from charged particles, weakening the field over time until finally, eventually, The magnetic grip loosens and collapse can begin. Your grip on consciousness loosening too, the magnetic field of awareness weakening, allowing you to drift, to fall, to collapse into sleep. No more resistance, no more holding on, just the gentle, inevitable surrender. Let everything go slack in clouds near the gene's mass, the critical threshold where gravity can overcome pressure. Something remarkable happens. The cloud becomes unstable, ready to collapse at the slightest trigger. It's balanced on a knife's edge, waiting. When collapse begins, in these genes unstable clouds, it's not sudden, not catastrophic. It's slow, like an avalanche in slow motion. The center falls first, pulling in. The layers above, which pull in, the layers above them, a cascade, spreading outward at the speed of sound through the gas, which is just hundreds of meters per second. Feel that slow avalanche inside your cell, starting deep at your core, spreading outward. Each layer of tension collapsing into the layer below, your muscles releasing one after another like dominoes falling in slow motion. Everything cascading, everything surrendering is to gravity, is to rest. Thump, thump. The collapse inside a gene's unstable cloud follows mathematical laws, but it feels organic, inevitable, like water finding its level, like you finding sleep, the universe pulling everything toward equilibrium, toward the lowest energy state, toward rest. In these avalanching clouds, density increases exponentially toward the center. The core forms first, then grows by accreting the infalling layers, each shell of gas adding itself to the forming protostar, building slowly, patiently, over hundreds of thousands of years, until finally the star ignites and the avalanche stops. Your avalanche towards sleep, nearly complete now, just the final layers falling, the last remnants of awareness cascading down, down, into the deep, into the place where stellar nurseries hide in darkness, where protostars grow in silence, where everything is quiet, still, and soft. And in the extreme nurseries at galactic centers, in colliding galaxies, in magnetically strangled clouds, in slowly avalanching cores, stars still form, life still finds a way, light still emerges from darkness. Despite everything, despite the chaos, the cold, the resistance, birth continues, patient, inevitable, endless, just like your breath, continuing, despite everything, despite the deepening of sleep, despite consciousness, fading, disappearing into nothing. The breath remains, the heartbeat remains, the slow, gentle rhythm of existence, continuing in the dark, thump, thump, or maybe nothing at all, just silence, just stillness, just the soft, complete, absolute rest of stellar nurseries, where everything waits in frozen darkness for the slow avalanche to begin, for gravity to win, for light to be born from the patient, endless, quiet, and we drift deeper still through mysteries, through darkness, through the places where stars hide before they're ready to shine, floating, falling, melting into sleep, into the gentle, cosmic dark, where collapse has only just begun in the coldest, darkest cores, temperatures so low that helium itself would be frozen solid if it could freeze. But helium remains gas even at 3 degrees above absolute zero, drifting, barely moving in the prestellar dark. Your body completely still now, barely breathing, barely there. Feel the weight or the absence of weight. You might be floating or sinking, impossible to tell. In the stellar nurseries, matter exists in this same uncertain state, neither fully cloud nor fully star, suspended in the long moment before collapse becomes inevitable. Some prestellar cores show signs of infall, gas moving inward, detected through spectral line analysis. Blue-shifted absorption on one side, red-shifted emission on the other. Proof that collapse has begun, even though the core still looks calm, still looks stable, the motion invisible except through careful measurement, like your drift towards sleep, invisible, imperceptible, but undeniably happening. These cores exist in a state called hydrostatic equilibrium, pressure pushing outward, exactly balanced by gravity pulling inward. Perfect balance, perfect stillness, but it's unstable equilibrium, like a ball balanced on top of a hill as the slightest push and it rolls, accelerating, falling toward the valley below, the core's weight poised for that push, that trigger, that moment when balance breaks. Let your mind balance there, on the edge, between waking and sleeping, not quite either, but poised, ready to fall. Any moment now, you'll tip and slide into the deep, the dreamless, the quiet. In some stellar nurseries, the magnetic fields are strong, strong enough to oppose gravitational collapse. The field lines thread through the gas, preventing it from falling. The cloud can remain stable for millions of years longer than it otherwise would. Eventually, the field weakens as the gas drifts across field lines through a process called ambipolar diffusion. Neutral particles slowly leaking away from the ions, the magnetic support gradually failing until finally collapse begins. Everything in the universe eventually gives in to gravity. Even light, bent by massive objects, cannot escape the pull. Even you, held to the earth by invisible force, sinking into the bed, pulled down, down by the planet beneath you. Everything falling, slowly, inevitably, toward rest. The Kennicutt-Schmidt law describes star formation across galaxies. It relates the rate of star formation to the density of gas, more stars, forming faster, but the relationship isn't linear. It's a power law, subtle, complex. The efficiency of star formation varies depending on pressure, temperature, metallicity, but everywhere, where gas is dense enough, stars form. The universe, determined to convert matter into light. Thump, thump. Your heartbeat now, a distant echo, like the pulse of the universe, converting matter into energy, into light, everything flowing from one form to another, nothing ever lost, just transformed. In stellar nurseries, some regions resist collapse. These are Bok globules, small, dark, isolated. They appear as black spots against brighter backgrounds. Each one contains perhaps 1 to 10 solar masses, enough for 1 or 2 stars. They're denser than typical cloud regions, more isolated, more private. Stellar nurseries for introverts, forming stars away from the chaos of larger regions. These globules were named after Bart Bok, who studied them decades ago. He predicted they were stellar nurseries before technology could confirm it. Now we know he was right. Inside these dark globules, protostars hide, forming slowly, quietly, in solitude. Eventually they'll emerge, dispersing the globule, revealing the infant stars to the galaxy. But for now, they rest in darkness, in peace, like you. Let the darkness hold you, soft, complete. Nothing to see, nothing to know, just the gentle absence of light, of thought, of effort. Everything dark, everything quiet, everything still. Some stellar nurseries produce intermediate mass stars, not as massive as O-type giants, not as small as red dwarfs. Somewhere in between, these stars, A-type and F-type, form less dramatically than their massive cousins. They don't carve huge cavities or trigger widespread collapse. They just form quietly, live their lives for 1 billion years or so, then fade. Nothing spectacular, but steady, reliable, the backbone of galactic populations. Most stars are like this, not extreme, not remarkable, just stars doing what stars do, burning hydrogen, shining steadily, drifting through space until they run out of fuel and fade, or swell, or collapse, depending on their mass. But all of them, born in nurseries, all of them, products of the same slow, patient process. Your breathing matches that patience now, so slow, each breath taking 10 seconds, 15. The pauses between stretching out, longer, longer, until you're not sure if you're breathing or if breathing has stopped and you simply exist in stillness. In the outskirts of stellar nurseries, where the gas is less dense, star formation is slower, more sporadic. Individual stars form in isolation, not part of clusters, not surrounded by siblings. They're called field stars, born alone, drifting through the galaxy, without companions, without memory of a stellar nursery, just lonely suns on solitary paths. But even these, were born from clouds. Even these passed through the same stages: protostar, class 1, class 2, main sequence, the process universal, unavoidable. Every star born the same way, through collapse, through accretion, through the slow heating of gas in the dark. Feel your body now, or don't feel it. It might have disappeared, dissolved into the mattress, into the air. You might be just awareness, floating, without anchor, without weight, like a gas cloud. Before it knows, it will become a star. In stellar nurseries viewed through radio telescopes, astronomers detect molecular emission lines, carbon monoxide especially, which traces the coldest gas. The intensity of emission maps the density, revealing structure invisible in other wavelengths, filaments, cores, sheets, the skeleton of the nursery laid bare by radio waves. Each wavelength reveals different truths. Optical light shows ionized gas glowing, infrared shows dust heated by protostars, radio shows cold molecular gas, submillimeter shows thermal emission from dust, X-rays show hot shocked gas in jets and winds. The nursery is all of these simultaneously, many layers, many truths coexisting, like consciousness, which has many layers, many simultaneous truths. But right now, those layers are collapsing, merging, simplifying into one truth, the truth of sleep, of rest, of surrender to the gentle pull of darkness. Some protostars eject material at relativistic speeds, nearly the speed of light. These jets are rare, seen only from the most massive, most actively accreting protostars. The mechanism isn't fully understood. Magnetic fields rotating rapidly, launching material from near the star's surface, flinging it outward at tremendous velocity. The jets carve through the cloud for light years, creating vast, elaborate structures visible across the galaxy. These are the screams of stellar birth, violent, powerful, terrifying, yet they're part of the process necessary to shed angular momentum, to allow the stars to form properly, violence enabling creation, destruction, and birth, intertwined, inseparable. But you don't need to think about violence or creation. Just rest in the space between, in the quiet, in the stillness that contains all possibilities without manifesting any of them. Thump, thump, or is that just imagination? Your heart so quiet, you might be listening to the echo of your own listening, awareness turning back on itself, dissolving into infinite regress, spiraling down, down into the deep. In the earliest universe, the very first stellar nurseries formed from pure hydrogen and helium. No dust to shield them, no molecules except H2. These population 3 nurseries were hotter, less dense. The stars they formed were massive, perhaps hundreds of solar masses, burning fierce and fast, living only a few million years before exploding. Their supernovae scattered the first metals into space, enriching the gas, making possible the next generation, the next nurseries, the long chain leading to us. We are descendants of those first nurseries, inheritors of their legacy. Every atom in your body, except hydrogen, was made in stellar cores or in supernovae. You are the product of countless stellar generations, each one forming in a nursery, each one living, shining, dying, contributing its matter to the next cycle. And now you rest, returning symbolically to the stillness from which you came, the peace of unformed matter, the quiet before birth, before light, before consciousness. Some stellar nurseries form in the wake of galactic collisions. When two galaxies merge, their gas clouds collide. The collision compresses them, triggering massive, widespread star formation. These starburst galaxies can form stars at 100 times the rate of the Milky Way. Their stellar nurseries, bright and fierce, create entire generations of stars in just a few million years, exhausting the gas, then falling quiet, leaving behind only the stars and silence. The antennae galaxies are an example. Two spirals colliding in slow motion over hundreds of millions of years. Vast stellar nurseries light up along the tidal tails where gas has been compressed, billions of stars being born from the chaos of collision, beauty from destruction. As always in the universe, let destruction and creation fade away. Neither matters now, only the quiet, the stillness, the absence of effort, of thought, of being, barely a whisper. Your body cooling, metabolism slowing as you sink into deeper, more restorative sleep, the kind of sleep that erases the day, that heals, that renews, everything letting go, everything surrendering to the natural rhythm of rest. In stellar nurseries around dying stars, planetary nebulae, sometimes new stars form. The gas expelled by the dying red giant is enriched with carbon, nitrogen, oxygen, elements forged in the star's core, now scattered, forming a new nursery, a new generation, born from the death of the old. The cycle continuous, unbroken, eternal. Our sun will do this. In about 5 billion years, it will swell, become a red giant, expel its outer layers. The gas will drift, cool, perhaps collapse, forming new stars, new stellar nurseries born from our sun's death. And those stars will have planets, and maybe those planets will have life. And maybe that life will look up at their night sky and wonder about stellar nurseries, just like you, just like this moment. But that's billions of years away. Right now, there's only this breath, this heartbeat, this moment of drifting into sleep. Some stellar nurseries contain high-velocity clouds, gas moving at abnormal speeds, perhaps falling into the galaxy from the halo or ejected from the disk by supernovae or left over from ancient mergers. These clouds, when they collide with the galactic disk, can trigger star formation, adding their mass to existing nurseries or creating new ones. The galaxy, constantly fed by infalling material from its surroundings, everything in the universe is falling into something else. Gas falls into galaxies. Galaxies fall into clusters. Clusters fall into superclusters. Everything pulled by gravity toward larger structures. The universe organizing itself through falling, through collapsing, through the patient, inevitable pull of matter toward matter, and you falling now into sleep, pulled by the gravity of exhaustion, of relaxation, of the body's need to rest, falling softly, gently into the deep, the dreamless, the dark. Thump, thump, in stellar nurseries does the final stage of collapse happens quickly, at least quickly by cosmic standards. Once fusion ignites, the protostar becomes a true star in just a few thousand years. The transition sudden, the star settles onto the main sequence and begins its long life of steady burning. But most of the time, the star spent forming was before that moment. Millions of years of slow collapse, gradual heating, patient accretion, all leading to that final moment of ignition when hydrogen nuclei overcome their repulsion, fuse together, and release the energy that will power the star for billions of years. One moment of ignition after millions of years of preparation, like sleep, which comes after hours of winding down, of relaxing, of letting go, until finally, suddenly, you cross the threshold and consciousness extinguishes like a star, igniting, but in reverse, light, becoming darkness, awareness, becoming nothing. Feel yourself at that threshold now, so close to crossing. The boundary thin, transparent, barely there. Just let go, stop holding on, and slip across into the deep, the quiet, the endless. Rest. Some stellar nurseries we've never seen. They're hidden behind dust in other galaxies, or simply too faint, too far away. But we know they're there because stars exist, because everywhere we look, we see stars of different ages, different masses, proof that stellar nurseries are forming them constantly throughout the universe. The nurseries we can see are just the brightest, the closest. There are millions more, billions more, scattered across the observable universe, all following the same process. Clouds collapsing, stars forming, light emerging from darkness, the universe tirelessly creating more sources of light, more points of warmth in the cold, vast darkness. And somewhere in one of those nurseries is right now, a protostar is beginning its final collapse toward fusion. Somewhere, a jet is erupting for the first time. Somewhere, a planet is condensing from dust, all happening while you lie here, drift, all happening in the darkness, in the silence of space. Your heartbeat and the universe's heartbeat synchronized. One rhythm pulsing through everything, the slow, patient, eternal rhythm of matter becoming light, of chaos becoming order, of nothing becoming everything, and everything returning to nothing. In the very centers of stellar nurseries, where protostars cluster most densely, gravitational interactions are common. Stars pass close, exchange energy. Some gain velocity, are ejected, becoming runaway stars. Others lose energy, sink toward the center, the cluster, organizing itself through these interactions over millions of years. The most massive stars sink to the center through mass segregation. They pull smaller star toward them. The cluster develops structure, a sense core, a more diffuse halo, everything organizing, everything finding its place, like thoughts, organizing themselves before sleep, then dissolving, losing structure, becoming formless as consciousness fades. Let your thoughts lose structure now. No need for organization, for coherence, for meaning. Just let them scatter, dissolve, fade into the formless background of near sleep. Some stellar nurseries produce exotic objects like magnetars. These are neutron stars with magnetic fields 1 trillion times stronger than Earth's. They form from the most massive protostars, at least 8 solar masses, stars that will explode as supernova, leaving behind collapsed cores, spinning rapidly, generating immense magnetic fields. But the magnetar itself doesn't form in the nursery, only its progenitor, the massive protostar that will one day collapse and become something strange, something extreme, all determined by the initial mass gathered in the nursery in those first few million years of formation. Everything determined by those early moments of collapse. The star's mass, its composition, its fate, all decided before fusion begins. The universe writing each star's destiny in the stellar nursery where it's born. Thump, thump, or maybe no thump at all, and just silence, deep, complete. Your heart still beating somewhere, but you're no longer listening, no longer aware of your body, of the room, of anything. Just darkness, just peace, just nothing. In stellar nurseries, at the moment of ignition, when fusion begins, the protostar stops collapsing. Radiation pressure from fusion balances gravity. The star reaches equilibrium and settles into billions of years of stability. The violent, chaotic, unpredictable nursery phase ends, replaced by the calm, steady, predictable main sequence. But that stability will end too. Eventually, the star will run out of hydrogen. It will evolve, swell, or collapse, depending on its mass. It will die, one way or another, and its death might trigger new stellar nurseries, the cycle continuing: birth, life, death, rebirth, endless, eternal, the universe, never stopping, never resting. But you can rest, you can stop, let go, surrender to the stillness. The universe will continue without you for a while. The stellar nurseries will keep forming, stars will keep igniting, galaxies will keep turning, all happening while you rest in the dark. Feel the darkness now, complete, total, enveloping you, like the darkness of a molecular cloud before any star has formed, before any light has emerged. Just potential, just waiting, just the slow, patient stillness before creation. Thump, thump, or not. You're beyond noticing, beyond caring, just floating now in the space between thoughts, in the space between breaths, in the space between moments, the space where nothing happens, where time stops, where consciousness just dissolves into pure, simple existence. And in that space, in that stillness, stellar nurseries drift, clouds of gas, waiting to collapse, protostars gathering mass, waiting to ignite the universe in the quiet moment before birth, holding its breath before releasing light into the darkness. You're holding your breath too, or maybe breathing so slowly it's the same as not breathing. Everything paused, suspended, balanced, on the edge, between being and not being. In the deepest stellar nurseries where the youngest protostars hide, the darkness is absolute. No light penetrates, even infrared is absorbed, scattered, lost. Only the faint thermal glow of dust grains, barely above absolute zero, invisible to every telescope, except the most sensitive, the stars there, forming in complete privacy, in total darkness, unknown, unseen, until they emerge millions of years later into the light. And that's where you are now, in the complete darkness, the absolute privacy of deep sleep, unknown, even to yourself, consciousness extinguished completely, your body, your mind resting in the deepest, most restorative just darkness, far from light, far from thought, far from awareness. The stellar nurseries continue their work, gravity pulling, gas collapsing, dust swirling, jets erupting, all in silence, all in darkness, all in the patient, unhurried rhythm of cosmic time, where 1,000,000 years is just a moment, where your lifetime is less than a heartbeat, where everything that matters to you is just a flicker in the endless night. But that flicker is enough. You are enough. Your rest is enough. There's nothing more you need to do. Nothing more. You need to be. Just rest. Just drift. Just let the darkness hold you forever, or just for tonight. It doesn't matter. Time has stopped, meaning anything. Thump, thump. The universe breathes. You breathe. The same breath, flowing through everything, connecting everything. The stellar nurseries the collapsing clouds, the forming stars, the dying suns, all breathing the same breath, all pulsing with the same slow, eternal rhythm. And we'll keep drifting, floating together through the mysteries. 100 Star Nurseries mysteries, looping softly, endlessly through the night. The gas clouds turning so slowly you'd never notice. The protostars gathering mass, grain by grain. The jets carving through darkness, silent, patient, eternal. The universe keeps turning, the soft cradles of star nurseries where light is born in silence, where darkness holds the seeds of stars, where patience is measured in millions of years, and everything is slowly, softly drifting toward light. And we'll keep drifting, floating together through the mysteries. 100 Star Nurseries mysteries, looping softly, endlessly through the night. Tonight we'll drift through the hidden cradles where stars are quietly born, the silent cosmic collisions that shape sparkling clusters, and the ancient clouds holding newborn stars you'll never see with your eyes. There's nothing you need to do now. Just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark,